Okay, here we are. Good afternoon, everyone. Nice to meet you. Thanks for joining. I'm Jonathan. I'm the CEO of Involve Space, and today we are here to basically broadcasting our launch from Frascati, here like 2 kilometers away. And we will have a lot of connection in real time between our mission control center in Como, the launch field here in Frascati, as well as the gondola, so the balloon flying into the stratosphere. We will receive probably some telemetries, some images, live video streaming. So we have a lot of content to share with you. And we probably are able also to connect and to speak directly with the mission control in Como. So here, for example, we are seeing our launch operators inflating the balloon. So we are probably in the last phases of our preparation. It can take 30, 40 minutes, probably. We are a little bit in delay, so things can happen. But yeah, we are here and we are really happy to share this moment with you. I think that we can probably already connect with the mission control. So I asked you the direction. Okay. So probably Rocco can hear me.
Yeah, I can hear you.
Perfect.
Good afternoon, everyone.
You are live here in Frascati from the ESA ESRIN Center. And so please let us know what you are doing, what's your role, and what we can expect in the next moments.
Yep, so I'm Rocco Corsini, I'm the Mission Operations Coordinator. My role is to keep in touch with the authorities to ensure that the launch operations are running smoothly and in compliance with all the regulations. Right now we are inflating the balloon. As you can see, there's a bit of wind, so we are trying to manage the operations as best as possible. The systems are on. We are just inflating all the necessary gas to make the balloon stand up.
Perfect, thank you so much. And we probably have some wind today, right? So what's your prediction for the trajectory?
Yep, so actually the wind at low altitude is blowing in the opposite direction with respect to the wind at high altitude. So for the first 2-3 kilometers of the ascending trajectory, we expect to move in the northeast, and then a sudden change will occur. So the balloon will then move more towards the west side.
So we probably pass over Rome, right?
Yeah, so the expectations are to pass over the city of Rome while doing during the high altitude trajectory. So when we are around 15 and 17 kilometers, and then we will start the descending trajectory, moving again toward west, and during the last 3 kilometers we will move back towards east.
Thank you so much, Rocco. So see you later, a few moments.
Thank you.
Maybe I can better explain you what we do and how we can control balloons flying, because this is a very important point. Balloons are not at the mercy of winds, but we can control the trajectory. So what guys in Como are doing, it is basically choosing the right trajectory and choosing the right altitude to meet specific wind stream. Thanks to that, we can basically move horizontally, and we can choose our trajectory, our direction. We can change again the altitude. We can go east or west. This is very important for us because, you know, when we want to track a specific infrastructure or a specific area on the ground, we have to choose to stay on it. So thanks to this pressurized system, we can basically control our attitude, our altitude, and even our trajectory. What do? We use balloons for a lot of things. The main thing we do is Earth observation, so remote sensing from the stratosphere, low altitude compared to satellites. This is an advantage because basically you can have high resolution data, but the most important point is the revisit time is basically zero because you can station keep above a specific area. You don't need to wait the satellite pass again on the same area of interest, so you can completely avoid this revisit time. This is really important for different scenarios like defense missions or when you need real-time monitoring on the ground. Imagine natural disasters or emergencies or when you need to monitor a specific infrastructure. So in this case, today we are launching one of our two balloon model. We have these two sites, let's say. One, the name is Stratostats. The other one is StratRelay. Today we are launching StratRelay that is basically lighter, more flexible, and can be deployed quite fast. Probably the entire operation can take 1 hour, and we can deploy the balloon. We can be up in the stratosphere in less than 1 hour. So this is really important for different scenarios. Again, dual use applications, or when you have a natural disaster, you want to deploy something like a flying guide that can help you understanding what's happening on the ground. This is really helpful because you can deploy it very fast. The other platform, Stratostats, is heavier. It is a little bit difficult to deploy, so you need maybe a launch pad, but it is perfect for flight validation missions. It is perfect to basically lift EV payloads up to hundreds of kilos. But again, you need more operations, you need more time. So we prefer to use StratRelay for Earth observation, even because our payload in this case is a camera. So can be around 1, 2, 3 kilos of mass. So StratRelay balloon, it is fine to deploy those kind of payloads. And another important point is, depending on the balloon, we can have different control systems inside the balloon to control altitude, to control the attitude. And again, we are basically able to control our trajectory thanks to these systems. On StratRelay, we have a basic valve that can control the ascent and descent. This is really helpful to change our altitude, but even to control our descent. So we can basically choose when we want to start the descent. We can basically choose the descent rate, the descent velocity, and this is really helpful for us to recover the balloon, recover the gondola, retrieve everything, and we can reuse balloons and gondolas again for the next missions. Stratostats, it is quite different. Basically, we have another pressurized system. We have this really powerful compressor that can inflate air from the outside. So basically, inflating air, we can go down, and deflating air, we can go up again. So we can change our altitude thanks to this compressor. So again, you have more components, and the platform is heavier than StratRelay. We recently implemented the StratRelay with a very important system. So we renamed our technology as StratRelay Extended. Why? Because now we have the live streaming to the ground. That is something that we already have on Stratostats, but something really tricky to have on StratRelay. We achieved this goal. So in this moment, we have a system that can send real-time telemetries and real-time data and real-time video stream on the ground during the entire mission. So thanks to a gondola that is around 2 kilos, we are able to do that. We are able to support a different kind of missions, dual use, civil applications, and even emergencies. This is really important for us because our clients can be also around the civil protection, and we can offer this help during emergencies. So I think now we are more or less at the 50% of the inflation phase. During the verticalization, that is our last phase before the takeoff, we basically have the balloon that is 50% inflated. So it is not a sphere. Why? Because the gas needs space into the volume of the balloon to expand during the ascent, you know. So thanks to the low pressure in the stratosphere, we can see the balloon expanding, and this can be really useful to float. So to stay up into the stratosphere and to, you know, fly for longer times and performing our missions. So you will see something like a jellyfish. This is the shape of the balloon during the verticalization and during the takeoff, because we need more space during the ascent. When we reach the apogee, in this case today will probably be around 18,000 meters, so 18 kilometers. We'll see this pretty cool sphere that is around 15 meters of diameter, so quite big. So yeah, I don't know if maybe the mission control are receiving some telemetries in this moment. I mean, they are preliminary, so from the ground, but maybe we can explain with Rocco some data we are watching. Let's see if the video direction can connect us again with the mission control. Yeah. Now we are watching our dashboard. So this is the dashboard that the mission control is using for monitoring every kind of aspect regarding the mission. So we have the map. We can see the point of our launch. As you can see, we are in Frascati. We have this very beautiful lake very close. And they are quite little, but we can see a lot of information about the coordinates, the altitude, the velocity, temperature, pressure, humidity, and a lot of information regarding our components and our system on board. So the battery voltage and the status in general of our systems. So this is really important for us to check that everything is going well and to solve any kind of problems really, really fast. In a second moment, we can also open the live streaming window, so we can try to connect with the gondola in real time to see if we can receive video streaming in real time. I think mission control is checking with the launch operators. Just to give you some information about the composition of our team on the launch field, we basically have 3 people. The main one is the launch commander, so is the person that is in contact with the mission control, in particular the flight director. So it is not Rocco who was speaking with me before, but the other, yeah, we are receiving the video streaming and we are on the ground. Launch director is speaking with the launch commander. This is a very crucial role because every kind of decision is made inside the mission control by the flight director. So flight director can communicate every decision taken to the launch commander. But most important, there's a checklist that we have to follow for 2 reasons. The first one is because of the regulations. So we are required to communicate with the aviation authorities. We have to check multiple times that our systems are good, are ready to fly, are nominal. But the second reason is we want to check that every system is working properly. So starting from the balloon, we have to check, thanks to some internal sensors, if the internal pressure of the balloon is the right one. This is a very important information to see if we are having some holes in the balloons or not. Then we can check some information about the gondola, so communication system, batteries, battery pack, solar panels. You have a very little mock-up here in the middle of the room, so you can see more or less the aspect of our gondola. This is just the gondola, so just the second part of our system, of the entire platform. So we basically have on the top the balloon. The size of the balloon can be decided based on the mission. And the good news is that we produce balloons in-house. So we can basically scale dimensions of the balloons based on the mass to be lifted. This is really important because now we have 2 models of balloons, as I told you, strat-relay and stratostats. But if a client needs something bigger or heavier, we can produce it. So this is a really important capability we have. And it is also something really fun because we are like 5 companies between Europe and the US producing balloons. So you don't have a book explaining how to do it. You have to test and try and fail and test again, testing different material. In this case, we are using polyethylene, so it is a plastic material, but still very expensive material because the radiation level we have into the stratosphere, but even the force and the lifting force we have to control between the balloon and the gondola is very high. So we need something very, very strong. And even the procedure and the process to produce these balloons is something really fascinating because it is basically hot sealing that can be used to put every kind of gore together to make this kind of orange. The balloon is a kind of orange that can be deployed after inside our missions. So yeah, we should be at the 60% of our preparation. Now the wind is more calm. Our lifting force in general is just lighter than air gas. So depending on the mission, we are using hydrogen or helium. Hydrogen is a little bit lighter than helium, so we need less hydrogen to inflate balloons. And it is also cheaper than helium, for sure. So depending on what we need to do, okay, we are verticalized the balloon. This is a crucial phase because on the top of the balloon, we have the valve. So is the component that can control our descending, but even our maneuvers, and should be connected always to the onboard computer inside the gondola. In this moment, we are using a system that is part of a kind of roll on the ground. The roll can help us to basically inflate the balloon and unroll the balloon during the inflation. We have a lot of winds now. And then we can have basically a release system can help us to deploy the balloon really, really fast. But we try to use also some kind of launch vehicles. So if you have more space, if you have more equipment, you can even use launch vehicles to help those kind of situation with the wind. You can basically take your balloon from the bottom, but even from the top. So you can, it is basically easier, yeah. So I think they are having some troubles with the wind. System are nominal. This is a good news. So today we are mounting an optical camera just for this demonstration. We are trying to use multiple payloads. So thermal camera, multispectral camera, hyperspectral camera, and thanks to our recent ESA contract inside the Incubed program, we will try to mount even SAR payloads inside the balloons. So this could be really interesting for, again, infrastructure monitoring and natural disaster monitoring, fast response to emergencies. A very, really cool application. We are partnering with a SAR payload manufacturer. So can't wait to test this new payload because it could be something really complementary to satellites, I think. And we can be a solution in the middle between drones and satellites. So when drones cannot fly and when satellites are not enough, we can be in the middle supporting any kind of missions on the infrastructure monitoring. Yeah, as you know, as you can see, our balloon now looks like a jellyfish, basically. Okay, since I am connected with the mission control thanks to this headphone, they communicate me that they are inflating the last part of the gas. I don't know if you can see on the right corner, but we basically are using gas tanks. In this case, for Strat Relay, this model of balloon, we are using 3 gas tanks. It is the equivalent of, yeah, more or less 8,000 cubic meters of gas. That's the quantity of gas we need to have the proper lifting force. And we are using hydrogen today. Have you experienced launch balloons before? Any projects, any kind of maybe school project, because there's universities using balloons, not those kind of balloons, maybe latex balloons, so the aerostatic ones. Also the military is using a weather balloon to test different components, but most important to measure meteorological conditions. So they are very important to do those kind of measurements. I think in Italy we have 2 launch sites from the aeronautics, where they are launching these very little balloons, latex balloons, to do this measurement. But we are still the only Italian supplier for stratospheric flights, because stratospheric balloons, so those kind of balloons made of plastic, they are really different compared to latex one. With the latex one, you cannot control the altitude, you cannot control the explosion. They will basically reach the maximum altitude, they will expand, the gas will expand, so they will reach a moment where the stress on the latex cannot resist to the pressure, the internal pressure of the gas. So they will explode, and you can basically recover your payload thanks to a parachute. You can do some simulation, some prediction on the descent trajectory, and you can recover them. Instead of those kind of balloons, you can basically control any kind of aspect on the trajectory and even the descent. So yeah, we are opening the last gas bottle. Yeah, we basically planned this moment since we have these 2 hours, to show you both the operations, so ground operations like preparation, verticalization, the takeoff, the first part of the ascent, reaching the apogee will be probably around 17 or 18,000 meters, and starting the descent, just for this demonstration. So yeah, thanks to these 2 hours, we should be able to see the apogee, and we should be able to receive live streaming from the stratosphere. I'm thinking about some curiosities I can share with you. Regarding the safety systems, we are required to have some components on board. In this case, we have 2 parachutes in the case of separation between the balloon and the gondola. That is something that the aviation authority is asking us to have. So you could have your valve controlling the descent, but you should also have a separation system in the case of anomalies between the balloon and the gondola. So you should have 2 parachutes, sorry, one for the balloon, one for the gondola. You should have a transponder on board communicating your position to other planes and aircraft. We have 3 redundancy of GPS position. We are even using GNSS, Galileo. That's really important for us because we can have this, redundancy on the position, really precise to know both the altitude and the position of the balloon. And we also have a beeper that is really important for the operations team to retrieve the balloon if it will land on a tree, for example. Okay, so maybe it is not simple to see, to catch. We have this beeper with a really important sound, so they can retrieve easily. And yeah, then we have 2 backups of our valve, so we can basically control the descent thanks to 2 important systems. From command, we are doing a command and control, so we have some autonomous systems performing on the gondola, but at the same time we can launch commands. So we can say, okay, valve please open, because we have to land right now, or we have to change position, we have to change the altitude, so we can send commands and we can control manually the platform flying, even if we have an autonomous system based on neural networks that we made based on a lot of data we catched from previous missions and even from mathematical models, because we have a lot of mathematical data on the stratosphere. So a lot of prediction, a lot of measurement, so we can basically design our trajectory based on those data and our own data that we catch from every launch. Yeah, okay, thanks for the zoom in. So we basically have latitude, longitude, altitude. We have some data regarding the velocity, angles of the camera, pressure, humidity, temperature. We are based in Como with the headquarters, so offices and our production site. We have a launch site in Arezzo in Tuscany, where we basically launch EV balloons. So that's really important to perform our own tests. We have an office and a launch site in Houston, inside the Houston spaceport. So it is really important for us to perform US missions to the US clients. But the very important point is that we can launch where it is needed. So we are in Frascati today. We can probably launch from your own city if necessary, if there's a client asking for a specific application, because balloons are really flexible. So asking for the authorization, the permit to fly, the NOTAM, you can basically be authorized for a specific trajectory and a specific diameter airspace where you can fly, and you can perform your launch when and where needed. Sorry?
Is the balloon still being inflated?
Yeah. You don't need a launch pad like a rocket, So it is really flexible because, for example, in this case, we are in the football field of Frascati, thanks to the Comune of Frascati. Thank you, Comune of Frascati. And, but yeah, for example, for other missions closer to Como, near Milan, we basically mapped all the city of Milan, launching from different points. And we did that from the track, directly from the track, thanks to a very little balloons. So really flexible.
To your knowledge, have there been any experiments by anybody in different balloon geometries trying to get balloons to stay in place? Obviously, you mentioned earlier they had trouble with the wind and things like that. As you expect, right? But I remember there being studies done, for example, like even like dead fish and swimming upstream and things the shape of their bodies, the pressure from the calm to shoot the distance behind pushes them forwards. I'm just wondering if there have been balloon geometries that have been done such that the balloon at least sort of stays roughly in the right direction, despite the
Yeah, there's a lot of geometry you can design. We tried 3 types of geometry. First one is the sphere, second one is the pumpkin, that is this case, and third one is something more like a kind of egg, let's say. So depending on the shape, depending on the design, you can basically differently distribute the pressure on the material. So you can obtain a different scenario of the altitude and the lifting force, and so again the trajectory. There are some studies regarding doing the same thing you are doing with balloons with the shape of airships, but we are not studying them. I think in this moment, for us, the best design we have is the pumping one, that is coming from Google Loon. Google Loon was a very important project on ballooning from Google. In this moment, the former CEO of the project is part of our board of directors, so we are obtaining a lot of information for our knowledge. And they were using pumpkin balloons. They flew balloons for up 1 year, constantly, all around the world, in particular in Africa, because the purpose of the project was to give connectivity to poor population, for example, in Africa. Very cool technical developments, but then it came Starlink, so they shut down. But yeah, they did a lot of things on the technical perspective they spent like $10 billion on the projects, so 1 billion per year. So they did a lot of things on the ballooning side. Before that project, the only informations you had on ballooning were from NASA ballooning program. They basically launched a lot of balloons, giant balloon to carry scientific payloads, but without any kind of control on the trajectory, just prediction on where you can land based on your mass and the quality of the balloon manufacturing. Let's try to ask to the mission operations if we have some updates on the operations.
Gas tank to finalize the inflation. In the meanwhile, I can give you some details. So the balloon is a 15 meters balloon. Is made of polyethylene, as Jonathan already said, but with a special formula just used for ballooning. So it's not that you can take any kind of polyethylene and craft your balloons. Well, you can, but they are not with all the properties that we want from a balloon. In particular, we want the balloon material to be as transparent as possible, as resistant as possible, as light as possible. So it's not something really easy to find, and also easy to weld. So we are using a thermal welding technology, and we need a material that behaves in a very uniform way when welded. For what concerns the inflation, we are using 3 full gas tanks, which amounts to around 600 bars of hydrogen. For what concerns the payload, we have an onboard computer recording temperature, pressure and humidity, the GPS signal, so the position in 3 dimensions, and 2 cameras, 1 camera for live streaming, 1 camera for remote sensing. The live streaming camera is pointing on a side of the gondola, while the remote sensing camera is pointing downward. Right now we have a 15 kilometers per hour wind blowing with gusts that are up to 25 kilometers per hour. The temperature, as you in all Italy, it's pretty high, so it's like 33 degrees Celsius. The pressure is pretty similar to the standard one at sea level, so 100 and 1000 Pascal. The estimated time of launch is from here, I would say in 15 or maximum 30 minutes, and the target altitude is 18 kilometers with a flight duration of approximately 3 hours and a half.
Thank you, Rocco. This is the suspense of the moment. If you have any question, I'm happy to answer, of course. I'm here for you. The inflation?
Yeah, the balloon.
Yeah, it is basically because of the wind today. So when you're wind, you have to pay attention to the oscillation of the balloon, and the same for the gondola, because it is a very strong material, but still something really delicate. It is plastic, so very special plastic, but it's still plastic. So you need something, some more attention. Yeah, I would say that usually it takes 45 minutes for the inflation and the preparation, and 45 minutes to reach the apogee. So you can be there in less than 2 hours. But sometimes you need more time. Also depending on the dimension, of course. This is, as Rocco said, around 15 meters of balloon. So if you probably use something more little, you can take less time. Maybe mission control can get an update on the inflation phase.
We decided to inflate a bit more of a fourth gas tank, just to increase the ascending speed and be sure to reach the target altitude. This is because of the wind, maybe some gas was subjected to some leakage, so is it better to margin a bit?
Okay, thank you.
So only 30 bar, only 30 bar. Okay.
Good news is that after the inflation phase, we basically have all the systems ready for the takeoff. So all the system, the electronics, the avionics, the communication system are set up before the inflation. So when inflation is completed, we basically are moving to the verticalization and the release of the balloon thanks to the countdown from the mission control, so we can take off in a few moments after the completion of this phase. So thanks for your patience. We should need some more moments. Yeah, that's a win today. Mission control, do you have an update on the wind condition?
Yeah, wind condition is the same as I said before, so 15 kilometers per hour mean,
Giacomo?
with gusts at more than 20 kilometers per hour. We are almost finishing the inflating phase.
2 minutes.
Okay. We should have updates on the takeoff, estimated time. Mission control, can you share with us?
Waiting for the signal.
The expected launch time is in 10 minutes.
Thank you. We probably should be able to see images in real time after the takeoff. So we will receive georeferenced images inside the map, but sharing with you some more details on the data that we can catch. We can basically reach around 30 centimeter pixel resolution, just to give you a more technical overview. And this is, of course, depending on the payload we are mounting. But yeah, let's say that the average is around 30 centimeter pixel. And the very cool thing is that we can receive data not just into a list, but we can see data into the map. They are overlapped into the map because of the georeferencing is running in real time. So we can receive every images, every shot into the map. Inside the map that we develop, we can even run analytics. So this is a very interesting tool that we are testing with our client. So for specific reasons, for specific applications, you can run analytics and you catch objects, you can catch data or vegetation data. Depends on the application. If you are watching infrastructures or natural disasters, or again dual-use applications. But our goal is to be really end-to-end, starting from the balloon production, the raw material, and the balloon launch, to the data and analytics for our clients. Why? That's because the majority of our clients, they are not coming from the space sector. So they are not technical people understanding what they are basically watching inside the platform. So they need to answer their question. They need answers. They are not waiting just for data, but they want answers. So is there a tree on my infrastructures? Yes or no? Object detection, that's the analytics that we have to run to provide this answer on the map. So not just providing the data on the map, on the platform, but helping our clients understanding what they are seeing and catching answer and taking decision. And in most cases, most scenarios, those kind of decisions can even help to save lives, maybe if you think about natural disasters, or save money in the case of infrastructure, or protect our nation in the case of dual-use application and defense applications. So. I see the third operator there with the other two, so I think they closed the gas tanks, the gas inflation. they're probably connecting the balloon to the security point and waiting for the wind. We already cut the inflation tube, that kind of piece of plastic you see on the left of the balloon. That's the tube for the inflation of the gas. Now it's detached from the bottle, so we concluded the inflation phase for sure. I don't want to disturb the mission control in this very crucial phase, so maybe we can wait. They are available for any kind of comment. They are operating the gondola closure and gondola and balloon connection. think they are finalizing the verticalization. Mission control, everything is ready.
Yes, the operators are connecting all the components, so the balloon to the parachute, to the swivel, to the gondola, attaching the fast release and verticalizing.
Few moments again. Okay. We are in the verticalization phase. Balloon is ready. Parachute and systems, safety systems are ready. Gondola is attached to the release system.
Okay, I'm starting countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Launch. Launch.
We are ready to talk. got it. Maybe. Okay, we are trying to connect with the gondola. Everything is nominal. We have the telemetries here. Mission control, everything is going well. We are basically receiving one telemetry every 10 seconds. So we can see the position and all the data in real time here into the dashboard. And in a few moments, we should be able to see even the live stream and the images. So mission control, can you give us an update on the ascent rate and the updated trajectory?
Okay, the balloon is ascending in a proper way. The current ascending velocity is around 4.3 meters per second. The trajectory is right now going towards the northeast as expected, but we also expect it to switch and go to the east after 2-3 kilometers of ascent phase. Now we will just wait for the live streaming and the first pictures once we go beyond 1 kilometer altitude.
Okay, thank you. Maybe we can just have the map with telemetries right now, waiting the live streaming. That is better than my face, basically. So. Okay. So going that direction, I think we should be able to take some photos of ESRIN, maybe. So you can retrieve that data and we can share images also after the launch. Okay, mission control, maybe can you share with us the updated prediction in terms of trajectory? I don't know if you have the graphic prediction you can share, or just explaining which kind of maneuvers we are expecting over Rome, I think. This is the last update I have.
Yes. So I have the trajectory in front of me now. So basically, we expect to fly in the northeast till Monte Porzio Catone until we have the reverse in the direction. After the reverse in the direction, we will reach the south part of Rome. So when we will reach around 17 kilometers altitude, we will be almost on top of Roma 70, so this neighborhood of Rome. And then we will pass over Centocelle, Palatine, Colline Palatine, Monteverde Nuovo, until we reach, we push in the direction of the airport, but we will then move more towards the north and land in the countryside in the north-west of Rome. So this is the current trajectory. I will show with you in a few minutes.
Okay, thank you. Can I stay connected with you, maybe talking about our details? You should be able to have some great photos over Rome after this mission. So maybe if you, Rocco, as the launch operations coordinator, can hear me, I want you to better explain to our people here how we can get these data, how we can catch these data inside our platform, how we can show this data to our clients, and you know, we have this product called Clear that can be very useful for different kind of clients.
Yeah, sure. So the camera is mounted, as I said, on the gondola facing the nadir pointing direction. So images of the ground are captured every minute. These images are saved on board on the OBC, and the OBC also manages to send these pictures in near real time down to our control center. Once the images arrive, they are automatically processed with a pipeline that moves them to Clear, which is our AI-based geointelligence platform, where they are automatically georeferentiated and available for the customers. So for this kind of mission, we used a sensor that could allow us to retrieve sub-meter pixel images with a swath between 3 and 5 kilometers. So basically, in the pictures at maximum altitude, so at 18 kilometers, we will see a square which is approximately 5 kilometers per 4 kilometers with a resolution below 1 meter pixel. All these images are, as I said, distributed using our platform. We also have some copies on other storage for different type of applications. These kind of images that we are taking today are in the visible spectrum, but we can also offer thermal and multispectral imaging.
Thank you. And can I ask you a more personal question? Because you are sitting on the mission operations right now, but you are inside the company since four years. So I remember sometimes where me and you were sealing balloons. So how do you feel about that?
Yeah, it was a wonderful journey. So we started from the bottom, from the startup, from 5 people who only had dreams. And right now we are running a company who is almost around 30 people, divided in different departments. So at the beginning there were me and Jonathan sealing balloons. Now we have a balloon manufacturing department with other people taking care of this. The same for launch operations. So there were times in which me and Jonathan were the responsibles to prepare the equipment, going to the field, perform the launch, and after the launch, monitoring the mission and perform also the recovery. Hopefully this is now responsibility of a dedicated team that you saw in the screens. So I would say we made a big step. These are not the only departments, of course. We have the technology, research and development departments, electronics part, mechanical part. But yeah, all started from small. Now it's becoming very, very well structured, and I'm proud of being on this journey with the company and with Inball Space.
I probably know the answer, but which was your funniest mission or funniest recovery?
Okay, so there are a lot actually. For instance, I remember one recovery in which I had to go to France. I remember once me and Jonathan had to go on a mountain around Lake Como. The view was wonderful, the effort a bit less, but it was fun.
Perfect. And maybe, you know, now we are 30 people, and the different kind of responsibilities are well divided. But when you start, when you run a company, you know, you have to do a lot of things together. You came from the aerospace engineering background, so what did you expect to do in your life choosing those kind of studies?
Okay, so as you said, when I joined, but even today, you have to work with different kind of people with different kind of backgrounds. I would say this is not really a problem. It's actually really motivating. Of course, it depends people by people. Like there's people that find themselves well just with engineers, technicians that want to work just with technicians. Actually, I like to work with different kind of people, so from technician to engineers, having also hands-on experience on everything, so having a look to the balloons, check that the balloons are fine, then go up, check, give a look to the software, to the dashboards, to ensure that everything is working well. Yeah, I really don't remember your initial question.
So we can speak about scaling a company is not just scaling production or people, but you are there inside the mission control, so it is also scaling operations. So how we want to face this challenge, because you know, now we are launching from Frascati, but maybe tomorrow we have to launch from another launch site, and we are doing a maneuver here. Another time we have to launch from Houston, etc. So in your opinion, as the mission operations coordinator working together with the flight director inside the mission control, where are the main challenges?
Yeah, so first of all, you cannot perform operations without a proper production. So scaling the production of the hardware in particular, because once you develop the software, let's say, is more easy to replicate. Yeah, but for hardware, we have to manufacture balloons, to manufacture gondolas, to manufacture electronic systems. So once the production is fitting well with the needs, to scale the operations, of course, more launch operators are needed. So you can both play with a good organization, so trying to group the launches in certain geographical regions, but at a certain point you will be limited by the number of people. So what I foresee is different launch operators groups made of 2/3 people, plus not one, but probably more than one mission operations coordinator and flight directors. So these are the two key figures that have to follow, prepare, plan, and perform the launches together with the launch teams. So if one flight director and one mission operator coordinator are following a launch, we can run another launch in parallel with other groups of people. So probably there will be an increase not only in the people, but also in the infrastructure. So having different mission control rooms, they can be all in the same building or in different buildings spread all over the world. Probably having them spread would help in better managing different customers and different geographical regions.
Great, completely agree. And thank you so much for your time, Rocco. Maybe we can connect again in a few moments. Just an update, if you have one, on the altitude right now and the direction again, or any kind of data we are receiving.
Yeah, I will check because I don't have. Okay, 3.7 kilometers is the current altitude for. Okay, the vertical speed is still around 4 meters per second as expected.
Okay, got it. Thank you so much. So we stay
Thanks to you.
connected on the dashboard, and the data dashboard. We should have some photos really soon. Yeah, this is our path, our trajectory right now. Okay, this is the first photo we got. Yeah, it is more tricky to have this connection with the mission control than compared to perform the mission, because everything is live streaming, so we also should coordinate with the mission control. We are taking photos. Perfect. Really cool. I don't know what is the position right now, if we are probably passing Frascati. We are probably around Frascati again. Should be around 4,000 meters of altitude. Another cool thing is that we have not to wait to go into the stratosphere to take photos, but even during our ascent or descent, we can take photos, and we can basically have this collection using the floating mode, so the floating phase into the stratosphere, to get more photos. Mission Control, maybe you have an update to share with our guests here regarding altitude and data we are acquiring.
Yeah, so the current altitude is around 5 kilometers, and the first images are coming, so in a few minutes they should be ready for you.
Perfect, thank you. Another component for you, Mission Control, just for your information, we have other 30 minutes here. So maybe we are able to show, some images, some telemetries, and again, giving some comments to our guests. So then we have to close this session and the live streaming can continue on YouTube, on our website, together with the telemetries and the datas. Got another one. Could be possible that is the Frascati railway station. I think they are giving a previous contribution on how are retrieving is performed. In that case, I think should be the last mission or one of the last missions. So our operators are there looking for the balloon. Of course, they know the landing point because they have the coordinates. They know the location. They are requested to take some photos for the mission control because every mission should have a proper report with all the information regarding the operations, the takeoff, the telemetries, but even the recovery. As you can see, during the recovery, the balloon is not completely deflated because of our descent mechanism. So we will basically release gas very, very slowly to guarantee this slow descent because it's very important for us to recover the balloon intact. We can expect it, we can reuse it for several times. In this moment, the reusability for balloons is around 5 times. The gondola, of course, is more, probably around 30 or 40 times we are using our current gondola. So as you can see, we have our little truck and we can go wherever you want to go, performing missions and recovery. Thanks for this unexpected contribution. I asked you the video direction. I don't know if you still have the feed from the launch site because operators probably are packing everything to start. Okay, they already did it really fast. Because yeah, next step is aligning with the mission control and then driving towards the landing point. Okay, so this is probably the prediction of our trajectory that Rocco was mentioning before. So yeah, starting point, the red point is Frascati, around Castel di Lesa Ciampino. The yellow point is where we will do the floating, so it is our apogee, the apogee point around 18,000 meters. Then we will do this maneuver over Rome and we will land on the purple point. Maybe if we have the connection with the mission control, Rocco can better explain this trajectory and why we choose and we are performing this specific trajectory, and any kind of update on the telemetries and the nominal status of systems.
Yes, so as you could see from the prediction, we chose that one because it passed exactly over the center of Rome. It will take at least half an hour, 40 minutes to pass over the center. And also the landing point is a safe point outside the city towards the countryside. For now, the status is going well, and actually the platform is flying at 8 kilometers altitude.
Okay, thank you. Yeah, sure.
What type of transmission band do you use to send the transmit images and everything? Is it VHF or other type?
Yeah, we have basically three different transmission communication system. One is based on satellite, another one is based on radio system, and the third one is just for the recovery phase, that is LTE. So it can be really helpful on low altitude during the recovery. So we have those kind of redundancy, let's say, as well as for the GPS, so we can be sure that we can receive telemetries and position always without any kind of loss of data. Of course, speaking mainly for dual use applications and defense application, we are also working with the defense to develop proper communication system with proper requirements for those kind of applications. So we are really open to integrate our system with the others based on the requirements of the specific mission. Mission control, are we able to receive any kind of images? I mean, I'm sure you are receiving images, and I'm sure it's tricky to share them with us in real time, but if you can do it, we can show something to here in ESA.
Yes, so we are receiving the images, but it's taking a bit to process. So as soon as they are ready, we will share with you.
Okay, thank you. Interesting fact is that we can even decide the frequency on the images shot. So in this moment, I think that the frequency is set on one image every 30 seconds. So we have a lot of images, and I believe it's tricky to process everything in real time. So yeah, we are receiving many and also selecting the right one and the one that can be used for any kind of purposes. It's not really easy. This is not just a commercial demonstrator, but it is still part of our test pipeline. So we basically launch 2 times per week in this moment. because we are implementing a lot of systems, and this is really useful for future implementation, future payloads, future features. This is really important for us, even to stress operations, scale operations, understanding how to be faster in deploying balloons, and also testing the launches from different points, different geographies, because every location is different, and the conditions that we may have in different locations are completely different in terms of wind, in terms of temperatures, humidity. So even the stress of operators during those kind of moments is really important. We have to measure it, we have to understand how to improve it. So it's really important to us to test frequently. This mission, we are testing new batteries, new energy systems, and I think even a new version of the software installed inside the onboard computer. Mission control, maybe we can have the last connection with you and the last sharing of data, since we are closing the session here.
Yep, so the trajectory is nominal. Actually, the altitude right now is around 9 kilometers. So unfortunately, because of the delay in the launch, we are not seeing the real passage over the Rome center, but we will receive the images after, when the lives close. The systems are working fine, so we are pretty happy. There will be a pair of systems to be improved, but I would say we will see where it will land, and we recover everything.
Thank you so much. So Rocco and Shrirup and the whole team of operations. So I want to mention Kevin, Maurizio, Giacomo, but most important, all the team behind all these implementations and our operations. So thank you so much for your time, for your connection. I ask to the video direction to still continuing sharing the telemetries and the data where the mission control is sharing with you. So the live streaming can continue for a little bit, and we are now closing the stream from here, from ESA, from Frascati. Thank you so much for our guests, and thank you again to the whole team.